So picture this. A top-tier consulting firm just successfully migrated this massive banking system to the cloud.
Right, the classic tech triumph.
Exactly. The client is absolutely thrilled. The new infrastructure works perfectly. I mean, the case studies are already live on the marketing site. High fives all around in the
Oh,
boardroom.
for sure. It looks great on paper.
It does. But behind closed doors, the consulting firm's finance team is looking at the margins in absolute horror because they just lost $2 million on the project.
Yeah, that's the dark secret of the industry right there.
It really is. And welcome to the deep dive, everyone. Today we're pulling apart a really eye-opening April 2026 article by Sue Ash from the Code Aura blog.
Which is a fantastic piece, by the way.
It's brilliant. It's titled, Why Most Consulting Firms Lose Money on Legacy Modernization Even When Projects Succeed. And our mission for this deep dive is to basically figure out the mechanics behind that invisible financial bleed. Like, why are these high-stakes tech projects looking like total triumphs while secretly bankrupting the firms taking them on?
Well, we really have to look at the root of the disconnect here. Because usually, when a tech project loses money, it's a visible execution failure.
Right, like servers crashing.
Exactly.
Yep.
Servers crash, the code is just dangerously buggy, deadlines are entirely blown, and, well, the client is furious. But that is not what Suash is highlighting in this article.
No, it's the exact opposite, actually.
Right. The code gets written, the system goes live.
Yeah.
The failure happening inside these consulting firms isn't an execution problem, it's an information problem.
An information problem.
Yeah,
Okay.
and understanding that distinction, that changes absolutely everything about how we view profitability in this delivery model.
So let's unpack that business model first, just so we're all on the same page. Because,
Yeah.
legacy modernization is traditionally framed as this massive cash cow for a consulting firm.
Oh, absolutely. It's the golden goose.
Right. You're taking on these ancient COBOL systems for global banks or, shifting monolithic databases for healthcare giants. And the source notes these deal sizes routinely range from $500,000 to well over $5 million.
Easily. Sometimes much more.
Exactly. You've got these fully built teams, steady revenue flowing for, 18 months or more. On the surface, it just looks like an ideal revenue stream.
Well, it is fantastic for top-line revenue, sure. But, and this is crucial, revenue is not margin.
Right.
Because these engagements, they're typically tightly scoped fixed bids, or at least tightly estimated.
Yeah.
So any friction in that delivery pipeline isn't just some annoyance for the project manager. It's a direct tax on the firm's profit.
The firm absorbs the friction.
Exactly. The consulting firm pays for it. If the dev team has to spend an extra month, say, just decoding a database structure, the client's invoice does not change.
Wow.
Yeah, that month of effort comes straight out of the firm's margin, not the client's pocket.
Okay, let's unpack this with an analogy. It's like buying a fixer-upper house on a fixed budget.
Okay, I like that.
Right. Every time you open a wall, you find 50-year-old wiring. You still finish the house, it looks great, but your renovation budget is entirely gone.
That is exactly it. You eat the cost of the surprises.
But wait, I'm struggling to buy this whole invisible argument from the article. I mean, these are sophisticated enterprise-level firms.
They are.
They have dedicated project management offices, they have dashboards, utilization metrics, software tracking literally every 15-minute increment of a developer's day.
Right, down to the minute.
So if the firm is tracking hours that closely, how does leadership not see the margin dropping in real time? How do millions of dollars just bleed out without a dozen red alarms going off for the CFO?
Well, what's fascinating here is how those traditional metrics are actually designed. They measure activity, right?
Right.
Not efficiency.
Okay, wait. Activity versus efficiency. Explain that.
So, leadership is looking at utilization rates. They see that the engineering team is billing 40 hours a week to the correct project code. They see that phase 1 milestones are, eventually getting checked off.
So the dashboard is green.
Exactly. The dashboard glows green. They assume the margin is holding steady because the team is fully deployed, and visibly they are working very hard.
Ah, I see. So as long as the engineers are busy, the system thinks everything is fine.
That is the trap. The dashboard measures how much effort is being exerted, but it doesn't measure the actual value of that effort.
Right.
If a senior developer spends 3 weeks manually tracing a data flow, just because there's no documentation anywhere, those hours are still logged as productive work in the system.
Even though they're basically running on a treadmill.
Exactly. The inefficiency is just accepted. It's institutionalized as, quote-unquote, part of the process of dealing with legacy code. The bleeding is invisible to the CFO because it just looks like normal operational work.
Which means the hours are tracked perfectly, but the actual value generated per hour is just falling off a cliff.
Spot on.
So where is that time actually going? Because the source breaks down 4 specific hidden cost centers, and it starts with the reality of what happens on literally day 1 of these projects.
Yeah.
Siyash calls it discovery chaos.
Yeah, discovery chaos.
Yeah.
So when a consulting team inherits a legacy system, they are almost never handed comprehensive, up-to-date documentation. It just doesn't happen.
Never.
The article notes that it's incredibly common for up to 40% of a legacy code base to be entirely undocumented.
Like 40%.
40%, yes.
That is, you're essentially taking over the architectural plans of a skyscraper, and almost half the blueprints are just blank pages.
That's a perfect way to put it.
Okay.
And that turns the standard discovery phase into this open-ended archaeological dig.
Right.
The team literally has to manually read decades-old code line by line just to understand the system's current state before they can even think about architecting the modernization.
They're just hunting for hidden dependencies.
Hunting for dependencies, buried business rules, you name it.
And if that archaeological dig takes twice as long as the initial estimate, which it sounds like it always does, it creates a domino effect.
A massive one.
Because if the timeline is blown during discovery, you suddenly have incredibly expensive people stuck doing the wrong kind of work.
Which leads us directly to the fallout of that chaos, which is the misuse of senior talent.
Yeah, let's talk about that.
Legacy projects naturally require highly experienced engineers, right? You need them to oversee the big picture architecture.
Makes sense.
But because of the discovery chaos, those brilliant, highly paid architects get pulled into tedious, low-leverage tasks. Instead of designing the beautiful future state cloud environment, they are spending their days decoding ancient logic.
Like trying to reverse engineer why some random database call was written a certain way back in like 2004.
Exactly.
So it's like you're paying a world-class neurosurgeon to sit in the basement and sort the hospital's mail. I mean, the mail has to get sorted, but it's an astonishing misuse of their specific talent. And honestly, just thinking about it, that sounds like a fast track to burnout.
The burnout is a critical factor here. I mean, top-tier engineering talent, they want to build, right? They want to innovate and solve complex architectural puzzles.
Yeah, they don't want to just be highly paid code translators.
Exactly. When they are relegated to that kind of mind-numbing work, they leave. Attrition strikes. And the cost of replacing senior talent mid-project, that further destroys the profit margin.
Okay, so if the senior architects are bogged down or they just straight up quit, what happens when the junior and mid-level developers take over to actually write the new code?
Well, they're flying blind.
Right. And that inevitably triggers the next massive margin killer the article identifies, which is rework. Building the wrong thing.
Yeah, and building on incomplete assumptions is arguably the most expensive form of inefficiency in software development.
Because you have to do it twice.
Exactly. The business logic in these old systems is so fragmented that the consulting teams often just have to make educated guesses to keep the project moving forward.
They have to hit their milestones.
Right, so they build a new feature based on what they assume the old code was doing.
And then it hits quality assurance.
Yeah.
And the entire thing shatters because they missed some obscure business rule buried deep in a forgotten module.
Which means tearing down the new feature and starting over from scratch. You are paying for the same deliverable twice, but you're only billing the client once.
It's a direct, unrecoverable hit to profitability.
Completely unrecoverable.
And the underlying reason nobody understands that obscure business rule brings us to the final hidden cost. And here's where it gets really interesting because it's an entirely human problem. Tribal knowledge.
Yes. Tribal knowledge.
In these legacy environments, the system isn't recorded anywhere. It's literally just remembered.
It's the Ask Bob strategy.
Yes. The Ask Bob strategy. It's like a family recipe where grandma just says, oh, just add flour until it feels right. But how do you scale a multi-million-dollar software migration when the official documentation is just Ask Bob on the 3rd floor? Because Bob wrote the payment module in 1998, so he's the only one who knows how the edge cases work.
You can't scale it. Ask Bob does not scale. If you are handling a massive migration for a global bank, you simply cannot rely on an oral history passed down around the water cooler.
It's insane to think that billion-dollar companies run on oral history, but they do.
They absolutely do. And if we connect this to broader industry trends, relying on tribal knowledge is becoming an existential threat.
How so?
Because in regulated sectors like banking and healthcare, The pool of engineers who actually understand legacy languages like COBOL is shrinking rapidly.
Well, because they're retiring.
Exactly. People are retiring. So when Bob leaves, that fragile bottleneck completely breaks. The knowledge walks out the door forever, and the consulting firm is left holding the bag on a system that literally nobody understands anymore.
Wow. Okay, so we have discovery chaos, we have misused senior talent, rework, and tribal knowledge. But the really sobering part of this source material, I think, is the math.
The math is brutal.
It really is. It shows how these aren't just isolated hiccups. Like, if a project just had a slight delay in discovery, a good project manager could just buffer for it. But these inefficiencies, they stack.
They compound. Let's actually trace the financial life cycle that the article maps out, because it paints a very clear picture.
Yeah, walk me through it.
So imagine a firm wins a bid. They have a very healthy 30% profit margin estimated.
Okay, 30%. Sounds right.
The ink is dry, the team starts.
Yeah.
But almost immediately, discovery chaos hits, uncovering that 40% of undocumented code. That adds 15 to 25% more effort before development even begins.
Ouch. So that initial 30% margin just dropped to, what, 22%?
Right around there, yeah.
I mean, it hurts, but the project is still technically profitable at that point.
True. But then development kicks off. The team misinterprets the opaque logic, like we talked about, and that introduces 10 to 20% in rework.
Okay, so now the margin degrades down to around 15%.
Exactly.
Half the profit is just gone, and testing hasn't even started yet.
And then during testing, those dependency gaps, the undocumented connections that only the retiring engineers knew about, those extend the QA timelines by another 10 to 15%.
So that triumphant 30% margin is now sitting at maybe 5 to 10%.
If they're lucky.
Wow. And the article notes that once you factor in the emergency senior talent the firm had to pull in at the last minute just to save the timeline, the profitability sometimes hits zero, or even goes negative.
Yeah, the firm effectively paid money for the privilege of modernizing the client's system.
That is wild.
And you know what the most dangerous part of all this is?
What?
How gradual it is. It's distributed across different phases, different teams, over 18 months or more.
So nobody notices.
Right, there is no single catastrophic failure to trigger a massive course correction.
Nope.
The degradation is just normalized.
Which really begs the question. So what does this all mean for the industry? Are these firms just trapped in a normalized cycle of losing money forever?
Well, according to the blog, the industry's default reaction hasn't been to fix the root cause. They just institutionalize the inefficiency.
Wait, how do they institutionalize it?
They assume legacy projects will always be a messy disaster. So for the next proposal they write, they simply add a massive financial buffer. They inflate the estimated hours to cover the inevitable chaos.
Ah, but inflating the estimate doesn't magically make the delivery team more efficient. It just hides the operational bleeding from the client by charging them more upfront.
Precisely. And this raises an important question about systemic problems. Because if the problem is systemic, the solution cannot be project level. You cannot solve a systemic issue by just working harder or padding the timeline. Throwing more bodies at a poorly understood system does not create clarity. To break this toxic cycle, a firm has to fundamentally change the economics of how they deliver the work.
Okay, so let's transition to the solution then, because the article isn't just diagnosing the disease here. It's pointing to a massive paradigm shift. High-performing firms are breaking this cycle by abandoning that brute force approach.
Yes, and the defining characteristic of those top-tier firms is that they prioritize understanding before execution.
Understanding before execution.
Right. They treat documentation as an active, continuous asset, not just a byproduct you create at the end of the project. They recognize that efficiency is what actually drives margin, and you cannot be efficient if your team is guessing.
But how do you achieve that deep understanding without falling right back into the discovery chaos trap? I mean, you can't just snap your fingers and materialize documentation out of thin air.
No, you can't. And this is where the delivery model shifts from being effort-based to insight-driven. They externalize the system knowledge.
Okay, but how?
To achieve that at scale, without burning out those senior engineers we talked about, these firms are integrating AI-driven platforms like Codora at the very beginning of the project lifecycle.
Okay, let's spend some time on the mechanics of Codora because this really seems to be the core of the paradigm shift. Instead of deploying a dozen architects to manually read decades of spaghetti code, they use AI to map the system from day one.
Yes.
But how does that actually work in practice?
Yeah.
We are talking about massive, convoluted COBOL or mainframe environments. It's not exactly clean modern code.
It's not.
Yeah.
But think about how a modern large language model understands language syntax, right?
Right.
Now apply that capability to 30-year-old code.
Okay.
Codor doesn't just read the text. It acts as a static analysis tool that traces variables across thousands of files simultaneously.
Oh, wow.
Yeah, that is something a human brain literally cannot hold in its working memory.
So if a payment module from 1998 interacts with some random customer database from 2010, the AI traces that connection instantly.
Instantly. Whereas a human might take 3 weeks of trial and error just to find it.
That's incredible.
It maps the hidden dependencies automatically, it extracts the business logic, and translates it into plain English. It essentially auto-generates the documentation that the legacy system was always missing.
So it creates this searchable intelligence layer.
Exactly.
So instead of paying your most expensive structural engineer to blindly hit the walls with a sledgehammer, hoping they don't hit a pipe, you're using AI as an X-ray machine.
That's a great way to visualize it.
You see the pipes before you even write the quote. You see the entire topography of the code base, where the bedrock is, where the sinkholes are, before you ever break ground on the modernization.
And that X-ray machine eliminates the mystery up front. When the mystery is gone, the assumptions disappear. And when the assumptions disappear, the rework disappears.
Which saves the margin.
Yes. Furthermore, having that searchable intelligence layer completely changes the team dynamics. Junior and mid-level engineers can just query the AI to understand how a module works. They don't have to go interrupt Bob or the senior architects.
So the neurosurgeon gets to go back to actually doing surgery.
Exactly. The senior talent focuses on high-value, strategic architecture. The entire firm shifts from making money by billing endless hours of discovery to making money by executing with incredible efficiency.
And looking at the broader market, this isn't just about squeezing out a few extra margin points for these firms, is it?
No, it's about survival. Because legacy systems are aging. Regulatory pressures are only increasing. The older these systems get, the more complex they become, while the talent pool of humans who can actually read them continues to shrink.
Right. Bob isn't coming back from retirement.
He's not. Firms that refuse to adopt this automated intelligence-first approach are on a ticking clock. They won't just see smaller margins, they will become entirely uncompetitive.
Because their bids will be too high.
Exactly. Their proposals, which are bloated with those massive manual buffers we talked about, will be drastically undercut by firms using AI to map the systems instantly. It is a structural advantage.
It's a total reinvention of how technical consulting operates.
It really is.
And that brings us directly back to you listening to this deep dive. Whether you are managing a massive consulting portfolio, or you're leading a corporate team, or honestly just organizing your own daily tasks, the core lesson here translates everywhere.
Absolutely everywhere.
Sinking immense effort into a system you do not fully understand is a guaranteed way to bleed your resources dry. Real success isn't driven by brute effort, it's driven by efficiency and clear insight.
Right. It requires the discipline to stop executing momentarily so you can actually understand the environment.
Map the territory before you start running.
Exactly.
Well, we have covered a massive amount of ground today, from the quiet margin erosion of fixed bid projects to the compounding math of inefficiency, and finally the AI-driven shift that is completely rewriting the consulting playbook.
It's been a great discussion.
It has. But I want to leave you with one final kind of mind-bending thought to mull over. We just broke down how AI tools like Code can perfectly reverse engineer, trace, and translate decades of messy, undocumented human code into plain English.
Yeah.
If AI can act as the ultimate translator and map the logic better than we ever could, will the developers of tomorrow even need to know how to read code? Or will their entire profession evolve into simply managing the AI that translates human intent into digital reality? It's a fascinating thing to consider. Thank you so much for joining us on this deep dive, and we'll catch you next time.